So good afternoon, students. So sorry for the delay. So I'll continue with unit number 3, which is consequence assessment and engineering economics. The next topic is time value of money. So the value, or that is the purchasing power of a money at a particular time, it is called as, or it is known as, time value of money. A rupee that is in today's day, it is worth more than a rupee that will be received tomorrow. So this is kind of a phrase. So the present money income expected at a future date, it is lower than the money that is being held today. Money has a time value that we all know, and money today is valued more because of the following reasons. Money, it gives liquidity and an opportunity to invest it and earn a return, that is earn an interest on it. Then individuals in general, they prefer current consumption to future consumption only because the future is always uncertain and it involves risk as well. Next, capital can be employed productivity to generate positive returns, and an inflationary period, a rupee represents real purchasing power than a rupee a year hence. So since money has earning as well as purchasing power, money has also a time value. For example, suppose we have deposited rupees 200 in a bank with 10% rate of interest. After 1 year, the interest would be rupees 20 and the amount will become rupees 220. So at the end of the year, so it follows the rupees 220 expected 1 year hence in worth only rupees 200 today. So techniques for adjusting the time value of money or interest formulas are, while making investment decisions, computations will be done in many ways. To simplify all these computations, it is extremely important to know how to use interest formulas more effectively or more valuably. So before discussing the effective application of the interest formulas for investment decision making, the various interest formulas are presented. So interest rate can be classified into simple interest rate and compound interest rate, as we know all. So in simple interest, the interest is calculated based on the initial deposit for every interest period. In compound interest, the interest for the current period, it is computed based on the amount, that is the principal amount plus the interest amount till the end of the previous period at the beginning of the current period. The notations which are used in various interest formulas are P is equal to principal amount, N is equal to number of interest periods, I is equal to interest rate that may be compounded quarterly, monthly, semi-annually or annually. F is the future amount at the end of the year N, and A is the equal amount that has been deposited at the end of every interest period. G is the uniform amount which will be added or subtracted period after period 2 from the amount of deposit AI, or that is the equal amount deposited in the period of 1 at the end of the period 1. Next is the present worth method. In all engineering problems, the engineers encounter one important question, which is that the type of project which we need to select. So to select among the different alternatives, different methods have been evolved. There are several bases for comparing the worthiness of the projects, and these bases are as follows: present worth method, future worth method, annual equivalent method, rate of return method, and payback period. First one is the present worth method. Many economists prefer a present worth analysis only because it reveals the sum, the total in today's rupee, which is equivalent to a future cash flow stream. For example, rupees 110 is expected as a 1 year, hence its worth is only rupees 100 today. So if the rate of interest is 10% and if it is compounded annually, so this means the rupees 100, it is the present value of rupees 110 which is to be earned in a 1 year period. So under this method, the present worth of all cash inflows, that is the revenue, it is compared against the present worth of all cash outflows. Outflows meaning costs that has been associated with an investment project. In this method of comparison, the cash flow of each alternative will be reduced to time period 0 by assuming an interest rate I. And then, depending on the type of decision, the best alternative will be selected by comparing the present worth amount of the alternatives. So difference between the present worth of the cash flows, that is the inflows and outflows, referred to as the net present worth, that is NPW. And NPW determines whether or not the project is an acceptable investment or not. Next, conditions for present worth comparison. The different conditions to compare a present worth method following the estimating the interest rate that the firm wishes to earn on its investment, determining the service life of the project, determining the cash inflows over its service life, determining the cash overflows over its service period, and estimating the net cash flows, that is the inflows and outflows. So if there is a single investment proposal, whether a project will be selected or rejected, that can be made accordingly. So if present worth, the conditions are, if present worth is greater than 0, then we select the proposal. That is, it refers to as a positive NPW, which means the equivalent worth of the inflow is greater than the equivalent worth of the outflow. So the project definitely makes a profit. Next, if the present worth is less than 0, then we reject the investment project because the negative NPW means the equivalent worth of the inflows is less than the equivalent worth of the outflows. Next, if present worth is equal to 0, it remains indifferent to the investment. And if we have mutually exclusive alternatives, then present worth cash flows can be calculated by another two prominent methods, which are revenue-based present worth and cost-based present worth. In a revenue or profit dominated cash flow diagram, the profit revenue salvage value, that is all inflows to an organization, it will be assigned with positive sign. So the cost, that is the outflows, will be assigned with negative sign. So in a cost dominated cash flow diagram, the cost, which is the outflows, will be assigned with the positive sign, and the profit revenue salvage values, that is the all inflows, it will be assigned with a negative sign. So in the case the decision is to select the alternative with the maximum profit, then the alternative with the maximum present worth will be selected. So decision is to select the alternative with the minimum cost, then the alternative with the least present worth amount, which will be selected.
Class in the login ruina. Aro time de dujen jinga sa dila help mangi. Mo to mangana lui kung lui direct friendship ba siya.
Next is the future worth method. So future worth method, it is particularly useful in an investment situation where we need to compute the equivalent worth of a project at the end of its investment period rather than at the beginning of the investment period. So conditions for computing future worth method: determining the interest rate, estimating the service life of the project, estimating the cash inflows for each period over the service life, and estimating the cash outflows over each period of a service life. For a single project evaluation, if future worth is greater than 0, then project is accepted. If future worth is less than 0, then the investment proposal is rejected. And if future worth is equal to 0, it remains indifferent to the investment. So for a mutually exclusive alternative, future worth cash flows can be calculated by revenue-based future worth and cost-based future worth. In revenue-based cases, the alternative with maximum future worth amount will be selected, and in cost-based cases, the alternative with the least future worth amount will be accepted. Equivalent annual worth comparison, EAW. There are various alternatives for comparing the worthiness of a project equivalent annual worth EAW, and it is one of the most important methods for comparing engineering alternatives. So in an annual worth method, all the receipts and disbursements occurring over a period are converted to an equivalent uniform yearly amount. So equivalent annual worth comparison, that is EAW, is a popular method because of a year's profit and losses are taken into account. A large number of engineering economic decisions are based on annual comparison, and so the term equivalent uniform yearly amount is often being used. For example, cost accounting, procedures, depreciation charges, tax calculations, etc. These yearly cost calculation tabulations generally make the annual worth method much easier. So equivalent annual cost, that is EAC, indicates that the equivalent value of negative cash flow for disbursement is greater than the corresponding positive flow of receipts. We will use the term equivalent annual worth EAW when costs and receipts are both present. We will use the term equivalent annual cost EAC to designate comparison involving only costs. So conditions for computing EAW is to estimate the cash flows over each service period, estimating the service life of the project, and determining the interest rate. Comparisons are made with before tax cash flows, and EAW comparisons do not include intangible considerations. For single alternatives, if EAW is greater than 0, we accept the investment proposal, that is EAQ less than 0, and reject the investment proposal. And if EAW is equal to 0, then it remains indifferent to the investment. For multiple alternatives or mutually exclusive alternatives, if all the alternatives are revenue dominated, then all the alternatives with higher EAW will be selected. And also if the alternatives are cost based, the alternatives with least EAW will be accepted. So EAW consists of the following steps: completes the net present worth NPW, multiplying the amount of present worth by the capital recovery factor, that is EAW is equal to present worth amount by principal, interest, time, where A by P and IN is called equal payment series capital recovery factor. Then rates of return method. The rate of return is a percentage that indicates the relative yield on different uses of capital. Three rates of return appear frequently in engineering economy studies. Minimum acceptable rate of return, MARR. It is the rate set by an organization to designate the lowest level of return that makes an investment acceptable. Internal rate of return, IRR. It is the rate on which the unrecovered balance of the investment in a situation where the terminal balance is 0 and a discount rate at which NPV is equal to 0. Next, external rate of return, ERR, is the rate of return that is possible to obtain The external rate of return is the rate of return that is possible to obtain for an investment under current economic conditions. For example, suppose the analysis of an investment shows that it will realize an IRR, that is an internal rate of return of 50%. So rationally, it is not reasonable to expect that we can invest in the external market and get that high a rate. In engineering economy studies, the external interest rate most often will be set to MARR, which is minimum acceptable rate of return, minimum acceptable rate of return, MARR. Next is minimum acceptable rate of return. It is also known as the minimum attractive rate of return, and it is the lower limit for investment acceptability set by organizations or individuals. So it is a device which has been designed to make the best possible use of a limited resource, that is big money. And rates vary widely according to the type of organization, and they vary even within the organization. So historically, government agencies and regulated public utilities have utilized lower required rates of return than have competitive industrial enterprises. So within a given enterprise, the required rate may be different for various divisions or activities, and these variations usually reflect the risk involved. For instance, the rate of return required for cost reduction proposals may be lower than that required for research and development projects in which there is less certainty about prospective cash flows. Next is the internal rate of return. This will continue in our next class. You can give your attendance now in the chat box. Thank you. Those who have given the attendance can leave and can join for the next class. This is the extra class. Time has been given 3 p.m. You can join by 3:15. Max by 3:15. After 3:15, I'll log the meeting. Okay. You check the new link that I gave in the WhatsApp group. Thank you.